Hello, my name is Dave Shane from Boston Engineering, and I'm going to discuss the need for better characterization of the ocean environment during mine countermeasure operations and how our multi-profile UXV-deployed free-floating sensors can provide critical data at the point of need. Boston Engineering has supported the Navy extensively over its 25-year history, and we're well positioned to design, develop, and commercialize technologies. Our centers of excellence provide the technical backbone for our consulting and technology development, and our facilities provide structure for our team to excel. We're no stranger to robotic and sensor-based systems for the maritime environment and have supported transition of many of these products, including within the maritime space. I'm honored to represent my colleagues here at NAVSEA Days, and while not shown on this slide, are the fuel that make this engine run. The Navy is expanding its use of unmanned systems, specifically for dull, dirty, dangerous missions. PEO-USC is planning on using the MCM USV to provide standoff during mine countermeasure operations. However, the reality is environmental data collected at the host LCS or host platform is not necessarily similar to the environmental data at the site of operations. This difference in environmental conditions impacts the mission planning, which happens well ahead of sending the MCM USV to the mine threat area, and can require repeated sonar track measurements over the same area to provide useful data. The differences in measurements between the environment at the host vessel and the target environment can cause significant operational delays. MCM teams are in need of reliable and localized sound velocity profiles at the target location. They need a system that can be deployed by units in the area, either by surface platforms or mine countermeasure aerial units, and need near real-time data over the course of many hours. As shown at left, the current system requires hand or hull integrated deployment and achieves data on only an individual profile, whereas Boston Engineering's solution provides multiple profiles, extended persistence, and can be deployed by the MCM USV at the target area. Our solution is called SVP Sonde. This is a smaller than A-size drifting system that executes multiple vertical profiles over a 12 to 24-hour period. Its deployment flexibility, sensing package, and depth rating match the mission needs, and the satellite communications enable it to provide data from extended distances, including over the horizon. This technology is based on novel, low-cost, variable buoyancy sensor and salinity sensor technology unique to Boston Engineering, and originally pioneered for a NOAA hurricane monitoring sensor. SVP Sonde's specifications align with PEO-USC and mine countermeasure team needs, and over the course of the Phase 2 effort will provide multiple lots of units for testing to solidify this alignment. As I've previously mentioned, this technology benefits from other Boston Engineering sensing products, allowing for rapid development time and overall cost savings to the Navy. Our initial deliveries provide demonstration units for users, and the subsequent deliveries prepare for integration into the PEO-USC MCM mission package. Drawing attention to the prototype testing in July of 2021, I encourage anybody interested in this testing to reach out directly to me. We are interested in more eyes and broader feedback to provide an effective and appropriate solution to the United States Navy. SVP Sonde provides data for ocean measurement requirements. This free-floating device collects sound velocity profile data in the water column, helping to identify where temperature and/or salinity variations may impact sonar returns. Currently, this data is simply not recorded at the point of need. Understanding the environment specific to where sonar returns are recorded can help improve efficiency for MCM teams and reduce false readings. Providing multiple profiles within a 12 to 24-hour period provides temporal information regarding how the environment is changing and provides that at an appropriate operational tempo. Remote deployment can remove the need for operators in the MCM environment. The straightforward and common cylindrical form factor offers a range of deployment options across multiple platforms. Satellite communications do not require line of sight from the host platform and can remove shipboard integration by potentially an email-based reporting structure. These advantages and benefits identified by SVP Sonde correlate into measurable and tactically relevant benefits to PEO USC and mine countermeasure teams. We're actively working on how to transition this to the fleet. We believe at the conclusion of the Phase 2, we will have prototypes that can be tested by PEO USC, which will effectively demonstrate the capability. We believe we can achieve TRL 6 or TRL 7 in the Phase 2, but recognize that achieving higher TRLs will require additional funding. To mature the system for fielding a second Phase 2 may be an ideal choice. The team is currently engaging with PMS 406 and PMS 420 to ensure testing opportunities are realized, as it is critically important for the solution to fit the need and to fit the user base. To get ahead from our end, we're actively in discussions with the MCM USV manufacturer to support potential deployment strategies and potentially leverage reachback SBIRs to execute that independent development. Our key points of contact are identified on this slide. We're encouraged by their enthusiasm and politely and respectfully offer them as points of contact. We would expect first prototypes at the end of FY 2022, with the potential of an LRIP beginning as early as the end of FY 2023. We're getting ahead on transitioning and partnerships. We are actively planning on executing sales through our company, leveraging our long-standing and successful relationships with local contract manufacturers. We have support ongoing from the state of Massachusetts via a START grant to support business and marketing across all of our vertical profiling technologies. Today, we're actively interested in meeting with program managers, key personnel, and other from PMS 408, 406, 495, 420, and 505. Additionally, other folks working on the MCM mission package that can help us turn this concept into a reality. Additionally, we're looking to expand into additional application spaces that have similar or tangential needs. If we can increase the quantity of the subassemblies or individual parts, we can drive down the overall cost across the entire vertical profiling enterprise. Thank you very much for your attention. As I close, I want to emphasize our interest in engaging with the community. I humbly request, if you identified something in this presentation that piqued your interest, potentially you have a new or alternate con-op for us, or something that sparked curiosity for some alternate applications, that you follow through and reach out. I can be reached via the contact information shown at the bottom of the screen, and additionally, I will be monitoring the virtual booth. Hopefully, you can easily navigate to it, and if so, I'll be there. Thank you again for your time, and I look forward to interfacing in person at some point in the future.